Hi everyone, last lesson we looked at the definition of a geometric sequence and we came up with a formula for calculating the nth term of a geometric sequence. In this video we'll look at a couple problems. So in the first problem we're told determine a formula for the nth term of the sequence 5, 10, 20, 40, comma, dot, 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 and use this formula to determine the 11th term. So first thing that I need to do is I have to identify this as a geometric sequence. I know that it's a geometric sequence because there's a common ratio. Notice that to get the next consecutive term, I'm multiplying by 2 to the previous term. So there's a common ratio between consecutive terms of 2. If I divide 10 by 5, I'll get 2. If I divide 20 by 10, I'll get 2. And if I divide 40 by 20, I'll get 2 again. So this is the common ratio. The common ratio is 2. So that is that R is equal to 2. The first term in the sequence is a, so we is 5. So we have that a is equal to 5, and thus we can come up with a formula for determining the nth term. So we have that t sub n is equal to 5 times the common ratio, which is 2, to the power of n minus 1. And the question asks us to figure out what the 11th term of the sequence is. So we're just going to use this formula to calculate the 11th term, which is t sub 11. So we have t sub 11 is equal to 5 times 2 to the power of 11 minus 1, which is equal to 5 times 2 to the power of 10. And 2 to the power of 10 is, let's see here, 2 to the power of 10 is 1024. Multiply that by 5 and we get 5120. So this is equal to 5120. Okay, so moving forward, in the second problem we're told in the sequence -3, 6, -12, 24, dot, 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 all the way to minus 3072, how many terms are there? So if we look here, notice that there is a common ratio of -2 between terms. So if I multiply -3 by -2, I get 6. If I multiply 6 by -2, I get -12. If I multiply -12 by -2, I get 24. And also, if you divide the consecutive terms, you'll find that 6 divided by -3 is -2, and -12 divided by 6 is -2 as well. So we can come up with a formula for the nth term. We know that t sub n is going to be equal to a times r to the power of n minus 1, where a is the first term, r is the common ratio, and n is the nth term, or is the term number, I should say. So we know that the first term, a, is equal to -3. The common ratio r is -2. So we have that t sub n is equal to a, which is -3, times -2 to the power of n minus 1. Okay, so in this question, we have to think about what we're asked for. We're asked for how many terms are there in this sequence. So basically what we're asked to figure out is what is the term number of this term. So what is n for this term? So we know that t sub n is equal to minus 3072, and we're trying to figure out what n is for this value. And we know that since the nth term can be calculated using this formula that we've come up with, we can equate this to -3 times -2 to the power of n minus 1. So now we can try to solve this equation. If we divide both sides of this equation by -3, we have that -2 to the power of n minus 1 is equal to minus 3072 over minus 3. And if you actually divide this out, we get that minus 3072 divided by -3 is 1024. And that's equal to minus 2 to the power of n minus 1. So the question is, what is n here? And to do so, to figure out what n is, we've got two choices. We could use logarithms technically here, or we can just rewrite the left side such that it has base 2. 1024 is 2 to the power of, let's see, it's 2 to the power of 2 to the power of 10. So we've got 2 to the power of 10 is equal to minus 2 to the power of n minus 1. Now, on the right side, I've got a base of -2, so I want to have a base of -2 on the left side as well. So -2 to the power of, 2 to the power of 10 is also equivalent to -2 to the power of 10, because when you raise a negative number to an even exponent, you'll get a positive number. So we have that -2 to the power of 10, which is equal to 2 to the power of 10, is also equal to minus 2 to the power of n minus 1. Now that the bases are the same, we can equate the exponents, and we have that 10 is equal to n minus 1. And thus, solving this equation, we have that n is equal to 11. So, therefore, there are 11 terms in the sequence.